In this video, we're going to talk about understanding and representing base 10 numbers. In our base 10 number system, we assign a place value to the numerals 0 through 9 based on their location relative to a decimal point. We sometimes call our base 10 number system a decimal number system. So this means if I choose the numeral 1 and I write it in this position versus 2 spaces away from the decimal, those have different meanings. Let's go ahead and label the different places. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. We can of course keep going, but this will be enough for our situation. Let's look at representations using unifix cubes and base 10 blocks. If we want to build a relatively small number, like 13, we can use unifix cubes. Here, we could have grouped 10 cubes together to make one large group of 10 to represent our number 13. This can get really unwieldy, though, when you get large numbers, so we might want to replace this with pre-made base 10 blocks. Here we have what we call a rod, which is a set of 10, and then I can have 3 individual units. Notice that each little cube here matches one part of our rod, and we can put 10 cubes together to form one rod. The rod has dimension 1 by 10. If I put 10 rods together, then I can form what we call a flat. So you can see that they line up here, and the flat contains 100 small units, and it has dimensions 10 by 10. If I take 10 flats and stack them on top of each other, I'll make this large cube. The large cube contains 1,000 small units and has dimensions 10 by 10 by 10. It's wonderful to work with the physical manipulatives. When we want to, however, represent the base 10 blocks on paper, rather than trying to draw those out, it would be really inefficient to try to draw, for example, a flat with 100 different little parts of the grid. We typically represent one. We're going to call it the unit, and we just represent it with a dot. 10, we often call a rod, and we're just going to represent that with a vertical line. 100, we often call a flat, and we're going to represent that with a square, trying to have, relatively speaking, one side of the square the same length as the rod. And then when we get up to 1,000, which we often call the cube, although I've heard it called a pack or other things as well, we want to show that we're adding another dimension on there. So just showing a little something there that we have a 3-dimensional number. So let's draw a number. Let's represent it in shorthand like we would in this class when we're communicating with each other. And then we'll go to another tool. In case you don't have base 10 blocks, we'll go to some virtual manipulatives. If I wanted to represent the number 1,423 with base 10 blocks, but using the shorthand, I'd use this key that I have up here. And so I'd have 1,000. I would draw 4 hundreds, 2 tens, 2 of the flats, and then 3 singles right there. Here we have some virtual base 10 blocks. So we had 1,400, so I need 4 of the flats, 400, kind of overlapped there, 20, 2 rods or 2 sets of 10, and then 3 individual units. And this really helps us see that when we have a 4 in the hundreds place, what we're talking about is 4 groups of 100. So looking at the numerals in each of the places, I'm going to omit the decimal. We usually do that with whole numbers, but it's still a decimal number. We have our ones, our tens, our hundreds, and our thousands. Ones, these are groups of 10. These are groups of 100. and these are groups of 1,000. The 1 was just a single. The 10, we represented it as a 10 by 1 object. The flat, the 100, was 10 by 10, and the thousands were 10 by 10 by 10. We can write these as the 10 by 10 by 10 becomes 10 cubed. 10 times 10 is 10 squared. That was a square object that we made. 10 times 1 is 10 to the first power, and 1 is just 10 to the 0 power. All of these ways of thinking about our different place values help us with expanded form. When we take the number 1,423, we could break it apart. This is 1,000 plus 400 plus 20 plus 3. We can expand this even further. The 1,000 is 1 group of 1,000. The 400 is 4 groups of 100. The 20 is 2 groups of 10. And then I have 3 ones, or 3 individual units. And then we can see the numerals that we recorded and the corresponding place value based on their location. We could also write this with powers of 10. All of these would be considered expanded form. Let's look at a different set of virtual base 10 blocks. Often elementary school workbooks will have a problem presented like this, where the child has to record the number. And of course, what you notice is that we have groups of 10 that have not yet been grouped together. So of course, every place can only have one symbol in it, 0 to 9. We can't put, for example, 25 in the tens place. So in these, we have to do some grouping. We can see that in the tens, we can group together and form a flat. So let's move this over here. And in the ones, we can group together and form a rod. So let's move that over here. And then now we have, we can represent each place with a numeral 0 through 9. So we have 2 hundreds, 3 tens, and 5 ones. 235. Let's move away from the physical base 10 manipulatives to base 10 number lines. There are lots of correct ways to draw a number line. In this class, when I ask you to draw a base 10 number line, I'm specifically looking for a number line that very clearly shows our groups of 10. So we're going to have short tick marks that we call minor ticks, and we're going to have long tick marks that we call major ticks, and the major ticks should represent groups of 10. We'll assume that all of our number lines start at 0, or if we pick up a number line somewhere in the middle, like at 100, we'll assume that if we worked backwards, we would get back to 0 as a major tick. So 0 is a major tick, and then each mark that I make, I'm actually counting the space. So when I count the first space, that's the end of the first space, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my next major tick represents 10 spaces. On a number line, I want to try to make sure that I have equal spacing if I can. So a number line should remind you of a ruler where each space has the same value, that they don't get closer together or farther apart. So after copying this several times, let's label them in different ways, each appropriately as a base 10 number line. So if I were counting by tens, starting at 0, 0, 10, 20, 30, 40, 50, I could label each major tick as tens, and then of course our minor ticks will be the ones. I could create a base 10 number line where the major ticks are hundreds. Starting at 0, if I count by hundreds, I'll have 0, 100, 200, 300, and then my minor ticks are going to be the tens, 10, 20, 30, and so on. Let's do a number line with the major ticks, thousands. So starting from 0, 1,000, 2,000, 3,000, and then my minor ticks are going to be the hundreds, one place value down. Sometimes people get confused and they'll try to do a base 10 number line, something like this. And they think, well, I'm counting by tens, and indeed they are counting by tens, but if we were to extend this number line back to the left, we wouldn't get to a major tick of 0. So we're starting at 0, and then we're counting by tens, hundreds, thousands, or whatever place we want. Let's plot 12 on each of these number lines. Here we have 12. This was 11, 12 right here. We're counting by ones on the minor ticks. 12 is going to be just to the right of 10 on the second number line, and 12 is going to be really close to the 0 on the third number line.